flood of Noah's day. It has been the source of legends, speculations, debates, movies, and persecution since it had occurred thousands of years ago. In the modern age of science, it has been further scrutinized and labeled as a myth. If the flood of Noah's day actually happened, why the debate? What does science reveal? Can we believe the story without physical evidence? I'm your host, Jonathan Rails. Join me as we search for answers. We will begin our journey with one of the tools scientists use that some say discredits the flood account. Should we quickly dismiss the flood without first examining what we do know? Let us find out. Welcome to the Vault, where we dive deep into history and mystery, beyond what you've been taught to believe. What if one of the most trusted scientific tools for understanding our past isn't as simple as we think? What if the clock we use to measure ancient civilizations, fossils, even the age of Earth itself can be influenced, distorted, or misread? Carbon dating. Reliable, misunderstood, or more fragile than we've been told? Tonight, we open the vault. Before we question something, we need to understand it. Carbon dating, more precisely radiocarbon dating, was developed in 1949 by Willard Libby, who later won a Nobel Prize for it. Here's the simplified idea. Cosmic rays strike the atmosphere. They create carbon-14. Living organisms absorb carbon-14 while alive. When they die, absorption stops. Carbon-14 begins to decay at a known rate. That decay rate, about 5,730 years per half-life, acts like a ticking clock. By measuring how much carbon-14 remains, scientists estimate how long it's been since death. It revolutionized archaeology. It helped date the Dead Sea Scrolls, Egyptian artifacts, prehistoric settlements. But here's the key question: is the clock always steady? Or are there variables we rarely talk about? Let's move from mystery to mechanics. Carbon dating rests on assumptions. And assumptions matter. 1. Atmospheric carbon variations. Carbon-14 levels in the atmosphere are not constant. They fluctuate due to solar activity, Earth's magnetic field strength, industrial emissions, nuclear testing, especially in the 1950s-60s. Because of this, scientists use calibration curves built from tree rings, a field called dendrochronology. But calibration only works as far back as the tree record goes. Beyond that, extrapolation begins. Extrapolation is not guesswork, but it is modeling, and models rely on assumptions. 2. Contamination. If a sample is contaminated, even slightly, results can shift dramatically. Sources of contamination include groundwater, soil carbon, handling, conservation, chemicals, microbial activity. For very old samples, even tiny modern carbon contamination can make something appear thousands of years younger. Likewise, ancient carbon contamination can skew dates older. This is why labs pre-treat samples aggressively, but perfection is difficult, especially in porous materials like bone. 3. Reservoir effects. Here's one many people have never heard of: the marine reservoir effect. Organisms living in oceans may absorb old carbon dissolved in deep water. That carbon has been out of atmospheric circulation for long periods. Result: marine organisms can appear hundreds of years older than they actually are. The same applies to freshwater systems in certain conditions. Without correction, dates mislead. With correction, we rely again on models. 4. Upper limits. Radiocarbon dating is generally reliable up to about 50,000 years. Beyond that, remaining carbon-14 becomes so minimal that readings approach background noise. At that point, the clock becomes statistically uncertain, so when we hear dates close to that limit, we should understand they carry larger margins of error. Now the real question: if there are variables, assumptions, contamination risks, calibration models, can carbon dating still be trusted? Here's what's important. Carbon dating is not used in isolation. In archaeology, it is cross-checked with stratigraphy, pottery styles, historical records, ice cores, other radiometric methods. When multiple independent methods converge, confidence rises. When they conflict, scientists investigate, and this is crucial. Carbon dating has been tested against historically known events, for example, artifacts of known age from Roman times, medieval manuscripts, ancient Egyptian materials. In many cases, calibrated radiocarbon dates fall remarkably close to recorded history. That consistency is one reason it remains widely accepted, but widely accepted does not mean unquestionable. Science survives on scrutiny. Some critics argue atmospheric conditions in the distant past were drastically different. Catastrophic events altered carbon levels. Calibration curves assume uniformitarianism. Supporters counter. Tree rings extend back over 10,000 years. Ice cores correlate atmospheric data. Independent isotopic methods confirm general timelines. So what are we left with? Not blind faith, not total doubt, but probability. Radiocarbon dating does not give absolute certainty, it gives statistically bounded estimates. When done carefully with proper calibration and cross-checked evidence, it is considered reliable within its range, but outside that range, or when contamination occurs, or when assumptions fail, results can shift. We've established something important. Water can affect radiocarbon dating through marine reservoir effects, through freshwater limestone systems, through groundwater contamination. These are documented phenomena, they're studied, they're corrected for, but they all assume something critical. Localized systems, defined environments, stable global baselines. Now step back. Let us look at the bigger picture. Across the world, separated by geography, language, and time, cultures preserve stories of a catastrophic flood. In their book Target, Earth Alan Kelly and Frank Dackil discuss the significance of what they call the universal legends of a flood of titanic proportions. They write,
"In the ordinary experience of man, floods are not of such great or of such widespread occurrence that he would generate a story of an overwhelming, all-exterminating flood. Except for some parts of the world, such as Japan, where tidal waves are quite destructive, floods are, and were, of little consequence to the security of man compared to the danger from wild animals, drought, famine, pestilential diseases, or even the intense winter storms in northern regions. Why then should practically all races of men have this legend of a great deluge? Why should people who lived far from the ocean in dry highland country, such as central Mexico or Central Asia, have a legend of a flood?
Different cultures, different continents. A common thread, a great flood. These stories do not by themselves prove a global geological event. Myths are not sediment layers, but they are cultural memory. And when similar themes appear across isolated civilizations, historians at least ask why. If there were a massive, rapid global redistribution of water and carbon reservoirs, what would that do to atmospheric carbon-14 ratios? Would ocean-atmosphere exchange spike? Would burial rates of organic matter shift suddenly? Would calibration curves reflect that disruption? Or would it appear as anomaly bands scientists already account for? The existence of water-driven dating variables raises a systems question. At what scale does disturbance challenge baseline assumptions? And if humanity collectively remembers water, could global contamination have been the reason we haven't found scientific physical evidence? The marine reservoir effect, hard water effect, and contamination risks are already documented in peer-reviewed research, and professional labs actively attempt to correct for them. Ask yourself, would large-scale environmental disruption affect the systems our dating methods rely upon? That is a discussion about system stability. Scientific tools are only as stable as the systems they measure. Examining assumptions is not denial of science, it is part of science. This is where layering data, history, and anthropology side by side lets you, the audience, sit with it and reason it out with your own critical thinking. You can make up your own mind. If seeing is believing, then the lack of scientific evidence in a global flood may be enough for some. On the other hand, those of us who believe the Bible to be God's word exercise not blind faith, but evident demonstrations of realities not beheld. Carbon dating measures decay. Flood stories measure memory. Science reconstructs the physical past. Culture preserves the psychological past. Sometimes they align, sometimes they don't, but both are data in different languages. So the final question isn't, is carbon dating wrong? It's this: if the planet once experienced something extraordinary, would we recognize it in the chemistry, or only in the stories? Most historians, both religious and non-religious, generally agree that Jesus Christ was a real person who lived in the 1st century CE. The earliest sources are the New Testament Gospels, written within the 1st century. In addition, several Roman and Jewish historians who were not followers of Jesus also mention him. For example, the Roman historian Tacitus wrote about Jesus' execution under the Roman governor Pontius Pilate. The Jewish historian Flavius Josephus also referred to Jesus and to his brother James. Because these references come from different authors, regions, and viewpoints, historians consider them valuable corroborating evidence. While scholars debate many details of Jesus' life, the majority agree on the historical truth. Jesus was a Jewish teacher and preacher who lived in Roman Judea and was executed during the governorship of Pontius Pilate. Even many skeptical historians agree Jesus existed. So it would stand to reason that what Jesus, the most influential teacher in history, thought about the flood of Noah's day might lend weight to the story. Should we at least take the story seriously enough to investigate it? The Jews who opposed Jesus wanted to stone him for claiming that he had seen Abraham, although, as they said, Jesus was not yet 50 years old. At John 8:58, Jesus spoke plainly of his prehuman existence as a mighty spirit creature in heaven before Abraham was born. Jesus claimed to be an eyewitness to the events that occurred in the Genesis account. When his disciples asked him about the sign of his presence and of the conclusion of the system of things, Jesus said,
"For just as the days of Noah were, so the presence of the Son of Man will be. For as they were in those days before the flood, eating and drinking, men marrying, and women being given in marriage, until the day that Noah entered into the ark, and they took no note until the flood came and swept them all away. So the presence of the Son of Man will be."
Jesus referred to the flood as a real event, claiming to be an eyewitness to events of that time. It would stand to reason then that he would have set the record straight if it were not true. Here he chose to use the event to compare that day with his presence during the time of the end. Perhaps the most noteworthy reference to the flood was not what Jesus said, but rather who Jesus was. He claimed to be God's Son. The prophecies in connection with him all had to be fulfilled in order that those believing in him would have solid evidence, a solid basis for faith. As a result, the Jews kept detailed records of their lineages to trace the Messiah back to the beginning. Part of that lineage was recorded at Luke, the 3rd chapter. There in verse 36 of that chapter, we find recorded that Jesus was a descendant of Noah. If he did not exist, or the flood did not occur, it would unravel the fabric of faith for those professing to be Christian. A reasonable conclusion when we step back and look at the full picture. The story of a great flood recorded in the book of Genesis begins to intersect with several lines of historical and scientific discussion. First, the flood narrative itself is not isolated. Cultures around the world preserved stories of a catastrophic deluge. From the Mesopotamian account in the Epic of Gilgamesh to the biblical story of Noah, many ancient traditions describe a massive flood that reshaped the world and nearly wiped out humanity. While these stories vary in detail, their shared themes suggest a cultural memory of a real event. Second, geology reveals that catastrophic floods are not imaginary. Science has documented enormous flood events such as the Missoula floods, triggered by the collapse of glacial Lake Missoula. These floods reshaped entire landscapes in a relatively short time, demonstrating that water can dramatically transform the Earth on a massive scale. Third, several geological observations often discussed in flood debates, such as vast sedimentary rock layers like those visible in the Grand Canyon, marine fossils found on mountains, and massive fossil graveyards, indicate that large quantities of sediment and organisms were buried rapidly in the past. While mainstream geology explains these features through long-term processes, catastrophic flooding is one interpretation that some researchers believe deserves consideration. Finally, the issue of dating methods is also part of the conversation. Radiocarbon dating assumes relatively stable conditions in the global carbon cycle. However, a truly global catastrophe, such as a worldwide flood mixing ocean water, vegetation, and sediments on a massive scale, could potentially disrupt carbon distribution. If such contamination occurred, it could complicate or skew radiocarbon results, making some dates appear older or inconsistent. Taken together, these observations do not conclusively prove a global flood, but they do suggest that the flood story preserved in ancient texts are not purely mythological. For many researchers and thinkers, this possibility invites a deeper question. If ancient traditions, geological evidence of massive floods, and unresolved scientific questions all point in the same direction, perhaps the flood narrative deserves to be explored not just as a story of faith, but as an actual chapter of human history.